In section 3.5, we're going to be actually introducing and covering two different integration techniques. This will be numbers 8 and 9 on our list of techniques that we've been developing. The first one here is what we refer to as the table of integrals, and the second is computer algebra systems, or what's abbreviated as CAS. Let's start by taking a look at the notes to see how the table of integrals actually ends up getting used. Here in the notes we can see that integration can sometimes be done using tables. Now, typically in a textbook, if you had a hard copy textbook for this class, in the front or back cover you might remember seeing all sorts of different things in math textbooks. You see formulas for basic things in geometry and sometimes things related to physics, and one thing that you might also see is a giant table of integrals. And as I state here, what this table shows is antiderivatives for a whole bunch of different complicated integrals. Now we're going to actually go ahead and take a look at how this would actually work with our specific textbook that we have for this course. Now you may not have actually ever pulled up our textbook, but you could easily just go to Google and do exactly what I have here, OpenStax Calc 2. Now if I click on this, I can see that my first link right here typically is going to be OpenStax. I can go down here and I can download a PDF if I wanted. I'm just going to go ahead and view online. Now notice that when I do view this online, there are a whole bunch of let me zoom out here just a little bit, but a whole bunch of different topics that are going to be covered in different chapters, and these tends to follow the order that we've been going through. Now, if I don't go through or into any of these chapters, but I look near the end, near like where the appendices would be, you'll see that even down here at option A, table of integrals occurs. I'm going to go ahead and click on that and then close my menu. And as I see down here, I have some basic integrals that I have antiderivatives for. Notice here, this is really easy on number 1. This is just like a power rule in reverse. And this right here is just the antiderivative of 1 over u, natural log of u. These are simple. In fact, a lot of these in the beginning are all antiderivative rules that we should already know. However, we can see that here are some other ones that we've developed. Antiderivative of a sine squared of u. Well, we started to use identities for that back in the previous sections. But of course the answer is just written right here. But the crazy thing is that this goes on for a long time, and there are tons and tons and tons of different basic kind of shapes or structures that have easy shapes or structures for antiderivatives. And so you'll notice here that this even goes into the hundreds. So there are a lot of these, and we want to try to understand in this section how we can actually use this list to our benefit. And so in the next video, we'll start by taking a look at some of the other examples that we have laid out here that deal with specific entries from that table of integrals, and we'll see how we can use them to evaluate a given integral.